Hello, class. We're going to be talking about Chapter 7, Section 3, which is solving systems using elimination today. With the elimination method, one of the most important things to remember is that you want to get rid of or eliminate one of the variables, either your x or your y or whatever variables you're dealing with. In a situation like this where you're given 5x minus 6y equals negative 32 and 3x plus 6y equals 48, it's not as easy to see which one we should eliminate. If we were to write them on top of one another like this, it becomes a little bit more clear. Because if you treat those as an addition problem, well, we've got 5x plus 3x, which gives us 8x, negative 6y plus 6y, it gives us 0y. We've just eliminated the y, which is our goal for this section, and we don't normally write the 0y. And then negative 32 plus 48 gives us 16. And then it becomes a one-step equation. Divide both sides by 8. You get an answer of x equals 2. Well, we know from the other two sections that that's not our solution yet. We've only got 1 point. So what do? Well, we're going to substitute it back in for x equals 2. We can either put it into 3x here or 5x, whichever one. I'm going to choose the 3x plus 6y equals 48 because there are no negatives there. That seems a little bit easier, don't you? Yeah, that's what I thought. So you substitute in the 2 for x, solve that like you normally would, and then you find out y equals 7. So your answer would be 2, 7. So with graphing or substitution, you come up with one single point, and with elimination, it's the same idea. 2, 7 is your solution. Well, they're not always going to be that easy. Again, you would write them on top of one another. 2x plus 5y equals negative 22. 10x plus 3y equals 22. Well, in this case, neither of these will drop out if I just add them together. So what do? Well, we can multiply one of the equations to get one of the variables to drop out. So in this case, I'm going to look at the 2x and the 10x. Is there something that I can multiply this 2x by that if I were to add to 10x, they would be eliminated? They would drop out. Well, very good. It is negative 5. And if you take that negative 5 and multiply it by the 2x, you're going to have to multiply it with the 5y and the negative 22 at the same time. So when I multiply every term by negative 5, I get negative 10x, negative 25y, and positive 110. I don't need to multiply this second equation. I'll just bring that down and bring down the plus sign also. And then just solve it like we did with the adding of equations. Negative 10x plus positive 10x gives you 0x. Again, we're not going to write that down. Negative 25y plus 3y gives us negative 22y. And 110 plus 22 gives us 132. One-step equation there, divide both sides, and you get an answer of y equals 6. And with that, again, you're going to substitute that in and show your work to figure out what x is equal to. And so then your final answer is 4, negative 6. So when you're working with elimination, you want to make sure that you remember that your goal is to reduce one of your variable terms to 0. Eliminate it. Get rid of it. Get it out of here. We don't want it anymore. It could be as simple as adding the two equations together, or you may have to multiply one or both of your equations to eliminate one of those variables. And just like in graphing and in substitution, you can always go back to Desmos to check your answers to make sure that it's right. So when you come to class, some of these problems are going to be a little bit more difficult. Give these two a shot. See if you can come to class with the right answers. Thank you very much. I hope you enjoyed Section 3, and I will see you in class.